Episode 33, Build, Electrical Rough-In. As mentioned earlier, a Radon junction box outlet needs to be installed in the attic for use with a vent fan should, after testing for radon, a more robust system be needed. We discovered that it takes forever to wire. It took us over 2 months to pull all the wires and install all the outlets and receptacles. Oh, and due to the COVID supply chain issues, the price of the wire was about 3 times what it should have been. Perhaps not the best time to build, and I was always running out of wire. Another 250 feet of 14.2, 14.3, 12.2, 12.3, and so forth. We started by having an electrician install our main electrical load center, connecting it to utility power. I then later added a sub-panel to support my numerous circuits. These panels were both plug-on neutral load centers. You should attempt, where possible, to have your wires presented neatly in the panels and your wire runs. In the design episode, I discussed the placement and other requirements of wiring. Here, I will just show some of the wire runs that I installed. Here's a standard run between outlets. Remember to comply with the guidance from the electrical design episode. Use wire nuts on wires and use screws on the receptacles. Don't just push the wires into available receptacle holes. Secure the wires in accordance with code. It's a good idea to take pictures of all your wires prior to covering them up so that you know later where they are and how they run. Make a loop of wire and put wire nuts on the end of the bathroom wall for above sink lights. You don't know yet where the wall receptacle will be. Make sure you have current guidance, pun intended, for 3-way and 4-way switch wiring. Have a diagram handy. Earlier 3-way wiring allowed for runs that are now illegal. There are different diagrams for the load at the end of the run versus the load in the middle of the run. One of the challenges that I had was to run the wiring for the kitchen lights. You can see here that the kitchen ceiling consists simply of beams covered with a solid wood floor. How and where would I run the wires to run these track lights? The solution was to route out a groove down the top center of the beams. This groove would be later covered by the wood floor. In this photo, you can see the wires run through the beams and into the lighting tracks. I have not yet installed the wood floor above. And here is the finished product. All wires hidden, all tracks and lights installed. In my earlier electrical design episode, I covered the different types of external receptacle covers. There are some covers designed for wet areas and some covers for damp areas. During your rough-in inspection, ask your inspector which outside areas he considers wet and which ones he considers damp. This lakeside face of the house does not have an overhanging roof on it, and this area is considered a wet area. Because it is a wet area, it requires a cover that protects the plug and receptacle at all times. This cover clips shut and protects the cord and receptacle even after the cord is plugged in. The other side of the house has the entryway roof over it. Receptacles below this roof are in a damp area, and therefore only require rain protection when they are closed. The receptacle covers here are simply individual covers, one per plug, that open so you can plug something in, and they do not protect against moisture when open. Episode 34, Build, Wi-Fi and LAN. My internet is provided by Garden Valley Technologies. Believe it or not, we are able to have gig-speed fiber optic internet to our lake home. They provide speeds up to 6 gigabytes per second. The technicians brought their fiber cable into the basement of the utility room and then ran it through the media converter. That's the large light gray box on the left. This converts the fiber optic signal to a digital electrical signal. From there, the signal goes into the modem, which is the dark black box on the right. The last item in the setup is the router, which is the center device. Initially, I went with an Asus router with mesh pucks, but the mesh system kept failing on me. I then changed over to the internet provider's preferred router, the Calix Gigaspire GS4220 Echo. I added 3 mesh pucks to the system so that I could have the same strength of internet all around my property. I placed a wired LAN in every room, and I even ran a LAN cable underground out to the garage. Having the wired LAN allows you to connect devices with no loss of speed or capability at a distance. This was especially important in the garage, which was quite a distance from the house. In the garage, I was able to hardwire a mesh unit and a security camera. Here you can see the LAN cables as I begin to install them. I elected to use Cat 6 cables, which support up to 10 gigabytes per second versus Cat 5e's 1 gigabytes per second. The Cat 6 cables are also designed to reduce crosstalk and interference. You can see the LAN wires in the lower orange boxes. For the wire to the garage, I dug a trench and then placed the Cat 6 wire in a 1/2-inch PVC pipe. The PVC will protect the wire. You can see here where the wire leaves the house. Episode 35, Build, Air Exchanger. I began by ensuring that I had an electrical outlet high on the wall near where the air exchanger would be. I then followed the instructions in the straightforward installation manual. Steps for installation included: hang the air exchanger from the joist with 4 supplied chains. Install the zone register terminals, ZRTs, in each of the 3 bathrooms. Install control panels in each of the 3 bathrooms. Run control wires from the air exchanger to each bathroom wall control panel, then run control wire from the bathroom wall control panel to the ZRT. Run uninsulated air ducting from each of the bathrooms to the air exchanger, merging the ducts into one duct prior to entering the air exchanger. Run 2 separate insulated ducts for outside air supply and return. Here's an external view of the intake and exhaust ducts. And finally, place a water pump to lift the exchanger drain water from the floor up to my household drain. These are really cool. These units up here that I use for the air handler are actually from a company over in France. And when you say, hey, I need a fan in the bathroom, currently it's just sucking air circulating through the house, but when I turn the fan on, the fan goes to high flow, and then once it's high flow, the valve opens right up, and then it takes all the moisture out of the bathroom and the shower, everything, and now it's ventilating the bathroom. And so there's quite a high flow of air coming through here right now, as opposed to its normal low flow. It goes down through the heat exchanger, so in the winter you're not losing your heat and humidity out. And that's all controlled here, and it's an all-DC system. It's controlled by this panel. And then when you said, hey, I'm done with it, and you turn it off, and the valve closes right back down, it would go back to low airflow continuous.